Good morning, student. Today we discuss variance and standard deviation. Variance. Variance is defined as arithmetic mean of the squared deviations of the observations from their arithmetic mean. So calculation of variance. For individuals, variance, that is sigma square, is equal to summation of capital Xi minus Xi x bar bracket square I running from 1 to n divided by n, where sigma square is equal to summation of xi square I running from 1 to n divided by n minus x bar square, where x bar is equal to summation of xi I running from 1 to n divided by n. Next is the frequency distribution. For frequency distribution, sigma square is equal to summation of fi in bracket xi minus x bar square whole bracket square I running from 1 to n divided by capital N, where n is equal to summation of fi I running from 1 to n, and x bar is equal to summation of fi xi I running from 1 to n divided by n, where xi is equal to mid value of ith class, and sigma square is equal to summation of fi in bracket xi square I running from 1 to n divided by n minus x bar square. Next point is standard deviation. A positive square root of variance is known as standard deviation. Standard deviation is denoted by letter sigma, which is equal to summation of root summation of xi minus x bar bracket square I running from 1 to n divided by n for individual observation. Next, sigma is equal to square root summation of fi into xi minus x bar bracket square I running from 1 to n divided by capital N for frequency distribution, and sigma is equal to under root summation of xi square upon n I running from 1 to n minus x bar square for individual, and sigma is equal to square root summation of fi xi square I running from 1 to n divided by n minus x bar square for frequency. These two formulae are used to solve the example. So first example, a couple has 6 children whose ages are 6, 8, 10, 12, 14 and 16. Find the standard deviation in ages. We have to given that this data. So solution: 6, 8, 10, 12, 14, 16. 1, 2, 3, 4, 5, 6. So n is equal to 6. And also we have to calculate mean. Mean, which is equal to x bar, which is equal to summation of xi divided by n, which is equal to summation this x1, x2, x3, x4, x5, x6. 6 plus 8 plus 10 plus 12 plus 14 plus 16 divided by 6, which is equal to 66 upon 6, and which is equal to 11. So x bar is equal to 11. Next, standard deviation. Is equal to sigma, which is equal to square root summation of xi minus x bar bracket square divided by n, which is equal to summation of square root xi means first x1 is 6 minus x bar, where we calculate x bar is equal to 11 plus x2 is 8 minus 11 plus square 10 minus 11 12 10 minus 11 square plus 12 minus 11 square plus 14 minus 11 square plus 16 minus 11 bracket square all divided by n, which is equal to square root n means 6 6 minus 12 is 5. 5 square plus 3 square plus 1 square plus 1 square plus 3 square plus 5 square divided by n, which is equal to square root 5 square 25 plus 3 square 9 plus 1 plus 1 plus 9 plus 25 divided by 6, which is equal to square root. Addition of this is 70 by 6, which is also equal to root 11.7, and root 11.7 is 3.42. So sigma is equal to 3.42. Next point is merits and demerits of standard deviation. So first is the merits. First, it is rigidly defined. It is based on all observations and is the good measure of dispersion. Demerits. It is difficult to understand and difficult to calculate. It gives more importance to extreme observations. Next point, properties of variance or standard deviation. First, effect of change of origin yi is equal to xi minus a. V of y is equal to v of x, or sigma y is equal to sigma x. Second, effect of change of origin and scale. Yi is equal to xi minus a upon h. V of y is equal to 1 by h square v of x, or sigma y is equal to sigma x upon h. Next, variance of the combined series. Combined variance, that is sigma c square, which is equal to n1 into sigma 1 square plus d1 square bracket complete plus n2 into sigma 2 square plus d2 square divided by n1 plus n2, where d1 is equal to x1 bar minus xc bar and d2 is equal to x2 bar minus xc bar, where xc bar is equal to combined arithmetic mean. So combined standard deviation. Sigma c is equal to square root n1 into sigma 1 square plus d1 square plus n2 into taking square root of combined variance, that is combined standard deviation as it is. Next is coefficient of variance. The relative measure of dispersion based on standard deviation is called the coefficient of variation. Coefficient of variation is defined as percentage of standard deviation to the arithmetic mean. So coefficient of variation CV, it is denoted by CV, is equal to standard deviation divided by mod of arithmetic mean into 100, which is equal to 6 upon mod x square into 100. Note, a distribution with relatively smaller CV is said to be more consistent than the other. Next, the series with relatively greater CV is said to be less consistent than the other. Using all formulae, that is combined variance, combined standard deviation, coefficient of variation, coefficient of variance, we solve the example. So next example is, the SAT scores of 100 students have a mean of 975 and standard deviation of 105. The GPS of the same 100 students have a mean of 3.16 and a standard deviation of 0.22. Which scores appear to be more consistent and why? First, solution. Given that we consider x1, capital X1 is event, that is SAT score of student, and x2 is GPA score of student. So for SAT student, number of students are 100, that is n1 is equal to 100, and mean is 975, so x1 bar is equal to 975, and standard deviation is sigma 1 is equal to 105, and for gap GPA score student n2 is equal to 100 student, mean is 3 point, x2 bar is equal to 3.16, and sigma 2 is equal to 0.22. We have to calculate coefficient of variance to check more consistent. So first CV for SAT score, that is CV1 is equal to sigma 1 upon mod x1 bar into 100, which is equal to sigma 1 is 105 and x1 bar is 975 mod into 100. After solving this we get 10.77%, and for CV GPA scores student, CV2 is equal to sigma 2 upon x2 bar into 100. Sigma 2 is 0.22 and x2 bar is 3.16 mod into 100, and also after solving this we get 6.96%. So here CV2 is less than CV1, therefore gap score of student is more consistent than SAT score of student. So our next example, from the analysis of monthly wages paid to employees into service organizations X and Y, the following results were obtained. Organization A, Organization B. Sample size for Organization A is 550, for B 650, mean 5000 and 4500, variance 900, and for Organization B 1600. So first calculate which organization pays a larger amount as monthly wages, and second find combined mean and standard deviation of all the wages earners taken together. Solution. Given that काय दिलेलं आहे आपल्याला, तर पहिले हा टेबल ड्रॉ करायचा. ऑर्गनायझेशन ए, ऑर्गनायझेशन बी, सॅम्पल साईज, मीन and variance. So sample space for organization A is 550, this is N1, and sample space for organization B N2 is equal to 650. Mean means x1 bar which is equal to 5000 and x2 bar which is equal to 4500. Variance means sigma 1 square which is equal to 900 and sigma 2 square which is equal to 1600. These are used. First we have to calculate organization pays a larger amount as monthly wages. For finding out which organization X or Y pays larger amount of monthly wages, so we have to compute the total wages as follows. For capital X, N1 into mean x1 bar which is equal to 550 is equal to into 5000 which is equal to 27,50,000. For Y, n2 into x2 bar, which is equal to n2 is 650 into x2 bar is 4500, which is equal to 29,25,000. So we observe that organization Y pays a larger amount as monthly wages as compared to organization X, that is Y is greater than X. So organization Y pays a larger amount as monthly wages as compared to organization X. Second case, we have to find combined mean and standard deviation of all the wages earners taken together. Second, we have to calculate combined mean and combined standard variation. For calculating the combined standard deviation, we will first calculate the combined mean. So for combined mean is equal to xc bar, which is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Here n1 is equal to 550, so which is equal to 550 into, we have to calculate n1 into x1 is 27,50,000. So use this value 27,50,000. And next plus n2 into x2 bar, we calculate 29,25,000 plus 29,25,000 divided by n1 is 550 plus n2 is 650, and after solving this we get 4,729.166. This is combined mean. Then combined standard deviations. So first we calculate d1, which is equal to x1 bar minus xc bar. X1 bar is 5,000 minus xc bar is 4,729.166, which is equal to 270.834, and d2 is x2 bar minus xc bar, which is equal to x2 bar is 4,500 minus xc bar is 4,729.166, which is equal to minus 229.166. Next we calculate combined standard deviation. So formula for combined standard deviation, which is equal to sigma c, which is equal to square root n1 into sigma 1 square plus d1 square plus n2 into sigma 2 square plus d2 square divided by n1 plus n2. So put this value, n1 is 550 plus sigma 1 square is 900 plus d1 square is d1 is 270.834 square bracket complete plus n2 is 650 into sigma 2 square is 1600 plus d2 is minus 229.166 bracket square complete bracket divided by n1 is 550 plus into is 650. After solving this square root, we get the answer which is equal to 251.868. This is the combined standard deviation that is sigma c. Thank you.